Hello everyone, welcome to Embedded Systems course with Arduino. In last sessions we interfaced LEDs through switches to Arduino, right? But we were only able to turn off or on the LED by providing either a 5 volt or a 0 volt, right, to the LED. We were not able to control the brightness of LED. So how do we do that? How do we provide a variable voltage or a variable current so that we are able to control the brightness of an LED, or even when we interface a motor, how do we control the speed of the motor, right? Because what will happen if you provide either a 5 volts or a 0 volts from Arduino, it will either run at max speed or it will either glow at the max brightness, right? But what will happen, right? Because Arduino in general has a 0 volts, right? Which is low, and your 5 volt supply which is high, right? So this can be your, either this can be your low brightness, right, lowest brightness, or speed, right, or this can be your max brightness, right? So this can be your max brightness or speed, right? So now what will happen if you want to control the brightness, right? If you want to control the brightness or speed of a motor or brightness of an LED, so you have to provide a, you have to provide a variable voltage, right? So you have to provide something like this, right? You have to provide a variable voltage to the peripheral so that the brightness or the speed is controlled. Now, but in general, Arduino does not have, any digital to analog converter. It does not have any digital to analog converter. Arduino does not have it. So what we do is we take the help of PWM signals, right? So what are PWM signals? PWM stands for, first of all, pulse width modulation. Okay. It stands for pulse width modulation. Now, as the name suggests, if you see, these are square wave signals, right? These are square wave signals. Now, the width of the pulse, right, is varying. Here it is some 25% time it is on. Here it is for 50% of the time it is on. Here it is 75%. So the width of the pulse, right, in these, right, width of the pulse is variable. Agreed? Right? Now this with variable width of the pulse will correspond to a variable voltage, right? So how will that happen, right? How will the variable width pulse correspond to variable voltage? So what will happen is, right, now this 0 volts, right, once you supply a PWM signal, so what can be the maximum duty cycle? Duty cycle can be 100. So duty cycle is, right, so if this is your duty cycle is what? So duty cycle is T on, the time for which the pulse is on or high, upon T on plus T off, right, the total period. So this is your duty cycle, right? Now, so the duty cycle max can be 100, right? So the variable voltage can be, you can put here the duty cycle, right, into the 5 volts, that this is the max amplitude. Agreed, right? This is the max amplitude which Arduino can provide. So this will give you the variable voltage. For example, your duty cycle is 50%, right? For example, this case, right? So what will happen? 50 by 100 into 5 will correspond to 2.5 volts. So this you can supply, right? Once you provide a PWM pin, a PWM signal on a Arduino pin and provide it to your peripheral, you can control the voltage, right? But how do we provide this variable voltage, right? We have to write something to the digital pins. Now we know that our digital pins, right, this 2 to 13, right? What you can do, you can write, you can use a analog write function which has a pin value, which has a pin, what pin you are connecting to or what pin you will be driving the PWM signals, right? And the value. So value is what? Value is an integer. Okay, this is your I can say some integer. Okay, this will be some integer, right, which will corresponds to 0 volts or 5 volts. So the write has, so this corresponds to value 0 integer and this corresponds to 255, right? So this analog write function provides you to map the value, right, between 0 to 255 for 0 or 5 volts. Now what will 2.5 volts correspond to? So 2.5 volts, for example, right, our output was 2.5 volts. So 2.5 volts can correspond to 2.5 by 5 into 255, right? Some integer, whatever the integer will come, that will correspond to, right, this particular voltage. So this particular voltage you will be able to write to the Arduino pin and thereby you will be providing this variable voltage. So this is what it is saying, right? Analog write 64. So if you write 64 value, it corresponds to 25%, right? So it will be something like 1.25 volts, right? This will be something 1.25 volts by this formula, right? Duty cycle 25 by 100 4 and then so 1.25 volts. Now this will be of course 2.5 volts, right? Then of course you can add, this will be 3.75 and this is your 5 volts, this, and this is of course your 0 volts. So in this you are able to provide a variable voltage to the particular pin, right, the digital pin, right, but you are actually providing a variable voltage. Okay, you are writing a digital integer, you are writing an integer, but that corresponds to some not only 0 or high value, but it corresponds to some intermediate voltage value, and that is how you are able to provide a variable voltage, right, an analog voltage through the help of pulse width modulated signals, right, where the width varies, the width corresponds to certain variable voltage and that variable voltage can be converted to certain integer, right, and that integer value we can write to the pin, and so the peripheral will understand that this particular variable voltage was provided, right? So now in today's circuit connection or the embedded circuit, what we are going to design, we will take a LED, right, we will take an Arduino and we will fade its brightness, right? So we will control the voltage. So you provide a variable voltage, right, and your brightness can be controlled. So components are same. If I take the components, right, nothing changes. As we have interfaced a simple, right, we take an Arduino Uno R3, right, and we take what? We take a breadboard. We take a resistor to control the flow of current so that the LED does not burn, right? And of course we take an LED, you can take a red LED, right? So these are the four components which we are going to use, but we are going to use that analog write method so that we are able to provide a variable voltage, right? And of course that analog write will provide a PWM signal, right? And those PWM signals with variable width of the pulses will correspond to variable voltage. Okay, so let's go to Tinkercad and start connecting the circuits. So we will go over Tinkercad, right? We'll click on circuits, we'll start designing this, create a fresh white space, right? Click on Tinker this. So from the circuit connection wise, nothing much changes, but I'm again reconnecting the circuit for you guys. Okay. So I took a, if you see, I took a Arduino. I took my ground and plus 5 volts, connected it to the plus row. So to provide it at 5 volts, this minus row, right, to provide it at 0 volts. And similarly, the upper minus and the plus rows, right? So that this is at 0 and this is at 5. We took a red LED, right? This is your red LED, and we took a resistor. So now what we have done, we have connected the anode, the long leg of the LED, right? We have connected to the plus 5 volts, and now let's take the other leg, right, and connect to a PWM, right, a PWM pin. So how do you recognize whether it is a PWM? This is a thing to understand. So if you see here the tilde symbol, right? If I click here D11, D10, you see here a tilde symbol 9 below it, right? Below the digital pin numbers, you should see the tilde symbol. Now this tilde symbol corresponds that it is PWM, and you see here it's written also, right? Digital brackets PWM, which is represented by this tilde symbol. So these are PWM pins. I connected my LED, right, to the PWM pin 9 or the digital pin 9, right? So my connection is done. The connection remains as simple as it, right? Now we only have to make sure that we are able to treat this ninth pin as a PWM signal, and that is where you control the voltage, right? You control the width of the pulses and you thereby control the voltage, or you provide a variable voltage. So let's go to the code, right? So code remains simple. I take a variable LED pin, which is my ninth pin, right? I take a brightness variable and I take a fade amount variable. So this fade amount variable is, I am asking that by in every run or in every time you fade the brightness of the LED by 5 digital points, right? I told you that it can, 5 corresponds to 255 integer and 0 volts corresponds to 0. So you increase in steps of 5. That is what this fade amount variable means, right? So I do my connections. Pin mode will tell me the direction of the pin, LED pin 9, right? It is an output because I need to control the LED, right? So I have declared this using the pin mode function, right? Now we want to repeat in every loop, or in this loop we want to decrease the brightness and increase the brightness. So first we will increase in steps of 5, and as we reach the limit, right, of 255 or 5 volts, we will start decreasing it. So it's very simple, that what we do, we first start from 0. So brightness is 0 and we write analog write, right? I told you that analog write will help you help write the value of the integer, which will correspond to some variable voltage, right? Now brightness I am increasing. I am increasing the value, right? So pin is a 9. This was a value. So value will correspond to some integer, which is my brightness variable. Now this brightness variable I am increasing by 5, right? In every time the loop runs. And if it reaches the end, if it reaches the 0 or the 255 limit, the digital integer limit, or the max voltage or the lowest voltage limit, you reverse it. If it is in highest brightness, then you start decreasing it. If it is also in lowest brightness, you again start increasing it, right? So we've just reversed the variable. We negate the variable fade amount and just wait for 20 milliseconds to see the dimming effect. This is what it is, right? So it's very simple, right? I am providing my PWM signal, a variable with signal. How I'm providing this? By changing the value of this brightness variable, right? It increases in 5 or decreases in 5 post it has reached the maximum. Now this value will generate a PWM signal, right? So every time every time this loop runs, it will generate a variable with pulse PWM signal, right? And that will change the brightness because it is ultimately changing the voltage which is supplied to the LED. So once again, I write analog write. I use the analog write function on the pin value 9. I provide the value, right, brightness value. So in next loop, it will be 5, 10, and like that till 255. It will go, right. And once it has reached that limit, it will start negating it, right. And it will wait for 20 milliseconds. You can see the dimming effect. So it will be very fast. So you just observe the LED from very high, it will start going low, and then from low to high, right? I will start the simulation. See, it's dimming, right? Then it's increasing. It's again dimming, again increasing. So this is your fading condition, right? So because I started from 255, right? This circuit was already at highest volt, right? And this will write the analog value will be written as brightness will be 0. So it will write that. Then the brightness will start increasing, and it will check the condition whether brightness was 0 or brightness was 255, and it will start decrementing it. If it is high or if it is low, it will start incrementing it. wait for 20 milliseconds to show the dimming effect. So this is what is happening, right? The brightness is decreasing and increasing. So this is how you can control the brightness. Also, if you want to, completely sweep through all the integer values, you can run a for loop, right? And put this analog write function and provide 0 to 255 values here, right? In the brightness, you can run a for loop inside this loop and just write analog write OLED pin and the variable which takes the value from 0 to 255, and again you can reverse it. So again that will show the same effect. Here we are increasing steps of 5, right? So that is what we are able to control the brightness. And similarly, if you are motor, which we will see in the next sessions, right, you can also control the speed or the RPM, the rotations per minute of the motor in this method, right? So that is how you control this. It's very simple, nothing else. Only the thing to look for is the analog write, right? Because this function is able to provide an integer value, right, between 0 to 255, which corresponds to a variable voltage number that is denoted by the pulse width of the modulated signal, right? The width is varying, the voltage is varying, and that is corresponding to an integer which I am changing and writing every time, right? So this is how you are able to control the brightness of this LED. Thanks for joining.